Sodium-ion batteries are creating a lot of excitement for the future of electric vehicles, with affordability being a key factor that could make them stand out. Today, the high price of electric cars remains a barrier for many, but sodium-ion batteries, which are much cheaper to produce than lithium-ion batteries, could change this dynamic. The great news is that this doesn't mean compromising on performance or quality. For instance, the Tesla Model 2, one of the most anticipated models, could benefit from sodium-ion technology, making it more accessible, especially for people looking to buy their first electric vehicle. Sodium-ion batteries function similarly to lithium-ion ones, which are already well known in the industry. Both types rely on the movement of ions to store and release energy, but they differ in the materials and processes used. In sodium-ion batteries, sodium is the main element. They consist of two electrodes, the anode, negative, and the cathode, positive. During charging, sodium ions travel from the cathode to the anode through the electrolyte. During discharge, the ions return to the cathode, releasing energy that can power electric motors. In recent years, significant advancements have been made in sodium-ion battery technology. Materials like iron and manganese compounds for the cathode, along with hard carbon for the anode, have shown promise by improving the efficiency of ion movement, enhancing battery capacity and lifespan. The electrolyte, which helps ions move between electrodes, has also been a focus of research, with efforts aimed at developing liquid and solid electrolytes that ensure stability and safety under various conditions. One of the key advantages of sodium-ion batteries is their safety. The materials used in these batteries have a lower risk of overheating or catching fire, which is essential for large-scale applications such as electric vehicles and energy storage systems. With ongoing improvements in material engineering, the future of sodium-ion batteries looks promising. Significant investments, particularly from companies like CATL in China, could reshape the automotive industry. With stricter regulations on lithium imports, Tesla may consider sodium-ion batteries as a strategic alternative. This technology could not only reduce reliance on lithium but also help the company maintain its tax incentives, making its vehicles more competitively priced. If Tesla adopts sodium-ion batteries, more affordable models, such as the Model 2, could be among the first to feature them, opening the door for cheaper electric vehicles. This aligns with Elon Musk's vision of making electric cars more accessible to the general public. The abundance of sodium, which is easier to extract than lithium, helps reduce battery production costs significantly. This price drop could make electric cars, like the Tesla Model 2, far more affordable and within reach for a broader range of people, thus increasing the adoption of electric mobility. Looking ahead, the lower cost of batteries could lead to lower overall electric vehicle prices. This would make electric cars more accessible to a wider audience, helping more people embrace the future of transportation. Electric mobility is already showing its potential, but its high costs still limit its widespread adoption. With the advancements in sodium-ion battery technology, that barrier could soon be overcome. With the help of sodium-ion batteries, Tesla and other automakers have the potential to revolutionize the market by offering more affordable yet efficient vehicles. Sustainability is another crucial factor in this shift. As we know, lithium is not a limitless resource, and its extraction can have significant environmental consequences. Sodium, however, is far more abundant and has a much smaller environmental footprint during both its extraction and processing. This makes sodium-ion batteries a great option, not only from an economic standpoint but also from an environmental one, aligning with the push for cleaner technologies. The real advantage of sodium-ion batteries lies in their abundance, lower toxicity, and greater ease of recycling compared to lithium. This addresses one of the key challenges of current battery technologies: what to do with batteries once they've reached the end of their lifespan. Sodium's simpler recycling process strengthens the argument that it could be the future of battery technology. It's almost as if the solution has been right in front of us, and we're just beginning to fully explore its potential. Another benefit of sodium is its widespread availability. Unlike lithium, which is primarily concentrated in specific regions such as Chile, Argentina, and Bolivia, sodium can be found almost anywhere. This reduces the geopolitical risks associated with lithium and makes global battery production more secure. It also lessens the market's vulnerability to supply chain disruptions. Additionally, the increased use of sodium could ease the pressure on the lithium market, which is already strained by growing demand due to the rising production of electric vehicles. By transitioning to sodium-ion batteries, automakers can help create a more stable and sustainable market in the long term. For automakers like Tesla, the shift to sodium-ion batteries offers significant advantages. Sodium is cheaper and easier to extract than lithium, which could lower the overall cost of manufacturing electric vehicles. This reduction in battery costs could also make other components, such as charging systems and maintenance, more affordable. Sodium-ion batteries are also expected to be more durable and require fewer repairs over time, further reducing the cost of ownership. This makes electric vehicles even more attractive, both for current EV owners and those considering the switch. The widespread use of sodium-ion batteries could also have a positive economic impact. As sodium is more widely available, the production of these batteries could spark the development of new industries in regions rich in sodium resources. This could lead to job creation and economic growth in areas that are not currently major players in the global battery market, offering new opportunities around the world. However, sodium-ion batteries are not without their challenges. One of the biggest limitations is their energy density, meaning they cannot store as much energy as lithium-ion batteries. This results in a shorter driving range, which would require more frequent recharging, particularly for those accustomed to the long distances that lithium batteries can support. In addition to energy density, sodium-ion batteries also fall behind in terms of lifespan. They currently don't last as long as lithium batteries before they begin to degrade, which could limit their appeal for some consumers. In some cases, sodium-ion batteries may have a shorter lifespan, leading to more frequent replacements. While this is a challenge, researchers are actively working to address it. It's an important factor to consider, particularly for technologies aiming to become mainstream in the future. Despite these hurdles, the potential of sodium batteries is undeniable. They are much cheaper to produce, which is a significant advantage in making electric vehicles more affordable. Additionally, sodium is plentiful in many parts of the world, so there are no concerns about resource shortages or the high mining costs that affect lithium production. This also means sodium batteries have a much lower environmental impact, as their extraction is simpler and less harmful compared to lithium. Another advantage of sodium-ion batteries is their easier recycling process. Lithium-ion batteries are more challenging to reuse, creating environmental concerns about disposal. Sodium, being less toxic and more abundant, allows for a more efficient recycling cycle, making the overall sustainability process more eco-friendly. While sodium batteries may not yet offer the same power as lithium-ion options, their environmental benefits make them an attractive alternative. Safety is another area where sodium-ion batteries shine. Unlike lithium batteries, which can overheat or catch fire in certain circumstances, sodium batteries have a lower risk of such issues. This provides consumers with greater peace of mind, knowing their vehicles are less likely to face dangerous failures. Imagine an electric car that's not only more affordable but also safer, which could encourage even more people to make the switch to electric mobility. However, for sodium-ion batteries to become a mainstream option, there is still work to be done. They need to improve in terms of energy density and durability to compete effectively with lithium batteries. Despite these challenges, many experts believe that sodium batteries will play a significant role in the future of electric vehicles. By reducing vehicle costs and contributing to a more sustainable future, they represent a promising alternative. Interestingly, sodium-ion batteries have been around since the 1970s but remained overshadowed by lithium-ion technology for decades. In their early stages, sodium-ion batteries held promise, but their energy density was too low, and they couldn't compete with the rapidly advancing lithium-ion batteries. However, recent breakthroughs in materials and design are changing this narrative. What was once seen as a limitation is now an advantage. Advances in materials like iron and manganese compounds have significantly improved sodium-ion battery efficiency, bringing them to a competitive level. Looking back, it's fascinating to think that sodium-ion batteries, which are now gaining attention, were once considered too limited for widespread use. If they had been widely implemented in the 1970s, the technology might not have been as exciting as it is today. However, with decades of material and manufacturing advancements, sodium-ion batteries now offer significant promise. They have the potential to revolutionize the electric vehicle market, providing a more affordable and sustainable alternative, especially considering the growing demand for energy solutions that don't rely on rare, expensive materials like lithium. Looking ahead, sodium-ion batteries could play a pivotal role in the shift to a low-carbon economy. As the technology continues to improve, these batteries could not only power electric vehicles but also be used in large-scale energy storage systems. Such systems are essential for integrating renewable energy sources like solar and wind into the power grid. This could transform the entire energy sector, making energy storage more accessible and efficient for a sustainable future. One of the biggest hurdles we face today is finding an effective storage solution, and while sodium-ion batteries show promise, there are still challenges to overcome. Currently, sodium-ion batteries don't match the energy density of lithium-ion batteries, meaning they store less energy in the same space. This becomes a concern for electric vehicles, where weight and space are crucial. However, with rapid advancements in electrode materials and electrolytes, this issue might soon be resolved. Despite this limitation, the lower cost and greater sustainability of sodium-ion batteries could compensate for the difference, making them a viable option for various applications. Another advantage of sodium-ion batteries is that they can be produced using existing infrastructure. Manufacturers that currently make lithium-ion batteries can adapt their facilities to produce sodium-ion versions with minimal modifications. This offers a significant cost-saving opportunity for companies and speeds up the adoption of this technology. The ability to offer a more sustainable product at a lower price makes this transition even more appealing to businesses. As the electric vehicle market becomes more competitive, introducing a more affordable and efficient battery could provide a significant edge for automakers. Those who integrate sodium-ion batteries into their most popular models, such as Tesla or more budget-friendly vehicles, stand to gain a considerable advantage by reducing costs and appealing to environmentally conscious consumers. Imagine a future where you step into an electric car powered by a sodium-ion battery, knowing it's both more affordable and better for the environment. This would represent a major leap forward for both the automotive industry and the planet. What's exciting is that this shift is only now becoming possible, thanks to continuous technological advancements. The true potential of sodium-ion batteries is just beginning to emerge, and the possibilities are vast. With further improvements, they could play a crucial role in the energy revolution that the world needs. Technological breakthroughs, particularly in the development of electrode materials, are helping sodium-ion batteries gain attention. What once appeared to be a limited technology with lower energy capacity compared to lithium-ion is now attracting interest. The inclusion of materials like iron, manganese, and hard carbon is making a big difference. These compounds, previously overlooked, are improving energy storage and efficiency, making sodium-ion batteries a more competitive alternative for electric vehicles. It may sound complex, but the concept is simple. These new materials allow batteries to store more energy and perform better. Iron, for example, is a relatively low-cost and abundant material that, when used in sodium-ion battery electrodes, helps improve charging and discharging efficiency. This is especially important for electric vehicles, as long charging times can be a major inconvenience. Furthermore, iron is more sustainable in terms of its extraction and processing, aligning with efforts to minimize the environmental impact of battery production. Another material that is gaining attention is manganese, which has a high capacity for storing sodium ions, allowing for greater energy density in sodium-ion batteries. This addresses one of the key limitations of these batteries, helping to improve their performance over time. Manganese also enhances battery lifespan, making it a crucial factor in ensuring long-term usability without frequent replacements. For those considering purchasing an electric vehicle, these developments make sodium-ion batteries a more appealing option. Hard carbon, while sounding like something out of a science fiction story, plays an essential role in sodium-ion batteries. It acts as a structural framework that allows sodium ions to move efficiently between the anode and cathode, making the entire battery more efficient in both charging and discharging. This seemingly small detail translates to faster charging times and longer battery life, improving the overall user experience. These innovations also address one of the key challenges of sodium-ion batteries, their lifespan. Since sodium-ion batteries tend to degrade more quickly than their lithium-ion counterparts, increasing their durability is crucial. With the introduction of these new materials, the batteries are becoming more resilient, allowing them to withstand more charge and discharge cycles before losing efficiency. This is a significant advantage for consumers who don't want to worry about replacing their batteries every few years. The use of materials like iron and manganese also has a positive impact on sustainability. These materials are more abundant and less environmentally damaging, which makes the production of sodium-ion batteries more eco-friendly. This fits well with the broader push for technologies that not only perform efficiently but also respect the planet. Electric vehicles are already associated with reducing carbon emissions, and it's only fitting that the batteries powering them follow a similar sustainable approach, using materials that are more readily available and have less environmental impact. Another important factor is the potential impact on battery costs. With cheaper and more abundant materials, the production costs of sodium-ion batteries could drop significantly, which would be reflected in the final price of electric cars. This could make electric vehicles more accessible to a wider audience, which is a major step forward in the shift toward sustainable transportation. After all, everyone wants a car that is affordable, efficient, and eco-friendly. What's most exciting about this development is how rapidly these advancements are taking place. Just a few years ago, sodium-ion batteries were seen with skepticism, but now we're starting to see their true potential. With improvements in electrode materials, we're getting closer to a future where these batteries can compete with lithium-ion batteries in terms of performance, but with the added benefits of being more affordable and sustainable. Tesla has long been a leader in electric vehicle innovation, and the rise of sodium-ion batteries presents an exciting new opportunity for the company. Imagine a future where Tesla no longer has to rely heavily on lithium, a resource that poses challenges related to extraction and cost. By adopting sodium-ion batteries, which are cheaper to produce and much more sustainable, Tesla could continue to offer affordable vehicles without raising prices. This would reduce the company's reliance on scarce and expensive lithium, allowing them to focus more on innovation and improving their products. Furthermore, adopting sodium batteries could help Tesla maintain its eligibility for tax credits, making their models more accessible to a larger audience. With lower reliance on rare materials, Tesla could keep its prices competitive, especially for models aimed at the budget-conscious market. This could be a game changer, allowing more families to experience electric mobility without breaking the bank.